Welcome everyone, this is Zon with Repro Products. Today's video is a tutorial on how to create a Revit family that is a bar stool. I found a bar stool picture online, just did a random search, and it looks like this. So we're going to use today's session to learn how to build all the parts of the bar stool, from the base to the stem, this little blend, and then the actual chair itself. And with that, let's go ahead and get started. I'll go ahead and move my image over to the side for now. And the first thing you want to do is open up Revit. And here I am in Revit 2018.2. We want to create a new family, so I'll click New. And by the way, this video that I'm creating for the family goes with the assumption that you know basic Boolean operations, things like sweep, blend, revolve, extrude, things like that. If not, it's okay because I'm going to go through that as well as I'm building the family. So when we start the new family, we want to take a look at the list of Revit family template files that are available. We're building furniture, so we'll head down and look for furniture.rft. RFT is Revit family template file. Click Open, and it'll give us a brand new file that's categorized as furniture. And the reason it's categorized as furniture is so that you can schedule it later within your project. And if I click up here under category, family category and parameters, you'll see it'll say furniture. And you also have a few other options down here as well. If you need to schedule this table, bar stool, chair out, and it's embedded inside another family, you might want to place a check mark for shared right here so that you can schedule it and at the same time tag it independent of the nested or hosted family. In this particular brand new family, we have two reference planes that they give you, one that's called center left right and one that's called center front back, and they both have define origin checked, which means the insertion point is here. And so we want to think about that insertion point, and does it make sense for this to be the insertion point? We're also in a ref level floor plan mode, so we're looking at this from top down. And so when we look at the picture and move the picture back over here, we want to kind of look at this chair and figure out how we want to build this. And so if we're looking at it from top down, we would see the seat, and then the post would be underneath, and then the base would be underneath. The first thing we want to do when we're building the family is build a skeleton system that defines the structure of this. We know we have a center reference line here for that pole. We need left and right and front and back reference planes to define the base, as well as the left and the right side and the back and the front of the seat. So let's move the picture over again. And some people prefer to work in different views as well. For example, if I switch to the front view, I get what looks like a blank view. If you type in ZA, you'll get to do a zoom all to fit, and you'll see your reference level. Select that reference level, and let's move it out of the way. The reason I do this is because there is a reference plane that's hidden underneath, and if you select it, you'll see that it's locked, and it also helps to define the origin. Since this is the front of the bar stool, we want to start creating planes for the left and the right side. So I will create a reference plane. RP is the keyboard shortcut. So as we move forward in the design of the bar stool, I'll be using a lot of keyboard shortcuts as well. We do want to make sure that this bar stool is equidistant from the center. So if it grows in width or height, that it grows consistently. So I'll place dimensions that show equality, and then an overall dimension for the width. DI is the keyboard shortcut, by the way, and I use the align command for that. We do want a reference plane that represents the top of the base, that little metal black plate that we saw. We need to have a reference plane that defines the top of the pole. We need to have a reference plane that defines that blended extrusion where it transitions into the seat. And then we need a reference plane for the back part that extends upward. And as you can tell, I didn't actually draw them in the correct dimensions. So for now, we can just place some basic dimensions that define the base. Excuse me, that define the pole, that define that blend, and then that defines the back part. Excuse me. Now, we want to head over to the floor plan view, and we know that this reference plane here is the center point, and this is also the center point. So we need reference planes for the back of the seat and a reference plane for the front of the seat as well. Excuse me. When you are creating the reference planes, things you want to kind of make sure are the ends, how they are aligning to each other. And that way it makes it a little easier to work with. We'll place, again, dimensions that define the seat, the depth of the seat, and the fact that it will be equidistant as well from that center point. You also want to give your reference planes names. So when you click the reference plane, you can click here where it says click to name and give it a name. So we'll call it back. And then over here, we'll call this one front. This one we'll call left. And this one we'll call right. Let's head back to the front elevation. And again, look at these. So I'll put this here as the back support reference plane top. It can be named anything that you want as long as you know what you've named it and it's consistent to you. So I'll click this one. I'll call this one the seat reference plane. Vertical support RP top. And then this one will be the base plate top RP. And then the bottom one, which was already given to you, doesn't have a name, so give it a name. Okay. Now, before we start building actual 3D physical geometry that is attributed to the reference planes, we want to kind of hone in on the shape of the skeleton. So we do know that from the picture, this plate looks like it's roughly 1/2 inch to 1 inch thick, and it has some radius curves. So let's go ahead and take this reference plane down here. Right now it says it's just shy of 2 inches. So if I select the reference plane, I can select the dimension, and I'll zoom in here. And it's kind of hard to read because it's really small font, but let's set that to say 1 inch for now. If we want that plate to grow in thickness, in other words, if we want the ability for the end user to change the thickness of the base plate as a parameter, then we would give this dimension intelligence. We would parameterize it. For the sake of simplicity, we can go ahead and select the dimension, and I'm going to lock it. In other words, this base plate will always be 1 inch thick. Now that I've done that, we can head over to the reference plan level. And if we look at the picture again, we can see that this plate is roughly the size of the seat. So I'll just use these reference planes as my framework to build that extrusion. So head over to the Create tab and click Extrusion. So what's an extrusion? An extrusion is when you take a profile that you've drawn, a closed profile in Revit, and it gets pushed or pulled a certain linear distance. So I'm going to click Extrusion, and in this situation I can use the rectangle command and draw it from this corner to this corner here. Now, the key to building families and making sure that they flex and adjust properly is how the relationship of the planes of the faces of the geometry associate themselves to the reference planes and reference lines and points. Here you notice that the magenta lines that I've drawn show the lock symbol. Go ahead and click to lock those faces to those respective reference planes. Once I've done that, if I just finish the command for the extrusion is created. I'll type in SD to go to shaded mode, and you can see that. This relationship is set up such that if I were to move this reference plane, you see it adjust accordingly on both sides and in the other direction as well. Now, since we want the base to have a curved radius, I can select the extrusion and click Edit Extrusion, or I can double click it and it goes right back into editing mode. Okay, this is called sketch mode. So let's go ahead and give it a radius. We'll fill up the corners and we'll give it a radius of 1 inch for now. I'll click this line, and it puts it in, and we'll lock the tangencies. So let's zoom in so you can see what's happening. And we want to do this for all 4 corners. Now, I can tell right off the bat that the radius that we picked of 1 inch is kind of small as compared to the picture. But that's okay, you guys get the point. So what I'm going to do is I'm going to delete those 2. And let's do that command again. And this time put in the radius of, say, 2 inches. Double the size. And again, locking the tangencies so it's a little easier. And the relationship of the endpoint of the lines with the endpoints of the arcs, they hold together nicely. This feature came out, I think, middle of 2017. Okay, so now that sketch looks nice, we can finish the sketch, and then we can head to the front elevation. Excuse me. Again, I'll put it in shaded mode, and the height of this, obviously we need to click and pull this edge and place it so that it aligns to that reference plane and lock it. That way it agrees to that reference plane and agrees to the 1 inch dimension. Don't forget, there is a bottom plane as well that is not locked. Click and pull that, or use the align command and do that as well. So now that we're finished, all I see is just the base plate. When you're working in Revit and you're building families and you get to a good point like this, always save your work. So we're going to go ahead and save File, Save As, a family, and I'm going to place it under my temp folder, and I'm going to call it Bar Stool. Now that that's finished, let's go ahead and build the vertical cylindrical support. And that's nothing more as well than a extrusion. That's a circle. So we can use the circle command here to draw that from the center point out. And I threw it in there and it says 3 inches in diameter, which is 6 inches. I'm going to click this dimension symbol here to make that dimension temporary, turn it to permanent. I'm also going to switch the scale for visibility to 1 inch. It makes it a little easier to see. Now this dimension, you may want to change the size of that vertical pipe support so that it can be adjusted down the road. So in that case, go ahead and parameterize it. And we'll call it post support. And I'll make it a type parameter, and it is a length because it's a dimension. And you'll notice I put an underline right here. I don't like using spaces because it's a little safer when you're doing formulas and things like that. I'll click OK. And now that it's parameterized and I finish it, I get that vertical post. Now let's head back to the front elevation. And again, you see, excuse me, the extrusion. We'll pull it up and align a lock here. Pull this out, pull it back so it touches the top of that reference plane, and align and lock that. Now, I can tell right off the bat that that post is too big diameter-wise. So let's change that to make it, say, 1.25 inches. Now it looks a little nicer, a little slimmer. There is, if we take a look at the picture, this blended extrusion with a little metal inner cylinder right here. So we need to adjust for that as well. So to do that, we will create another reference plane for that little cylinder portion. And again, when you create the reference planes, go ahead and set that up, place the dimension that you want, and let's say I like that dimension. Let's say I want that to be that thickness. I'll go ahead and lock that dimension. And then because of that, I'm going to move this dimension from 4 inches to this plane. And that way this can be adjusted if we need to. And I'm going to set this to 3 inches. And for now, I'm going to lock it to keep it simple. So we're going to have a chrome inner cylinder here, and then the blended extrusion here. So let's go back to the plan view. Let's go back to create. And let's start the extrusion command again. And do the circle. And again, draw the inner cylinder. Now, I can also dimension this as well. And we'll parameterize this. And we'll put this as post inner support, like that. Now, typically, that inner chrome support is going to be smaller than the outer support. So if you want to ensure that that always happens, you can go to your family types window, which I clicked over here. And in here where it says post inner support, we can make it equal to a formula. We can say it's going to be the post support minus a certain amount, say 1/4 of an inch. And if we do that, then it's always going to hold that relationship. We'll finish the command and again head back to the front elevation. It is selected. It's hard to see because we're in shaded mode. So let's go ahead and pull this up and pull it all the way up and out so you can see. And we need it so that the face of them line and lock to the planes that we need, which is this one and this one. Whoops, I missed it. Let's go ahead and pull in again and lock. Now, we need to do the blended support right here as well. So we'll head back to the plan view. And we'll draw the next one. Now that blended support, from the picture, if we look carefully, we can see that the bottom circle is slightly larger than the cylinder circle, but not as big as the main post support. And the top looks like it's the size of the post support. So we'll go back over here to create. This time we want a blend. A blend is when you take two different profiles from two different planes and they blend one shape into the other shape. In this case, we want two circles that are blending but of different radii. So let's go ahead and click blend. And by default, you're drawing the profile for the bottom. And the way you know that is because the command for edit top is available. So if I click edit top, it jumps to giving you the ability to adjust the profile for the top. So the bottom is the base. So I'm going to just cylinder again. And this time, it needs to be bigger than the chrome support, but smaller than the main post support. And this time, again, I'm going to take this and parameterize it. And I'm going to call this blend bottom radius. And because of that relationship, let's take the bend bottom radius and let's make it equal to the post support minus 1/8 of an inch. That way it's slightly larger. Then we can click edit top and then draw the top as well. And the top needs to be the same size as the post support. And again, parameterize that. So since we did parameterize the post support diameter already, or the radius already, we can just use the same one. And then we want to head over to the front elevation before we finish it. because what we want to do is click Edit the Base again, and we can go to Plan View, that's fine. And we want to look at the plane that we want to use. What's the plane that we want to use for the base? The base is right here. It's this plane, which when we drew it, we didn't actually give it a name. Okay, so let's click Edit Top instead. And we know that the top has a reference plane as well from the front elevation that we drew, which is going to be right here, that seat bottom. So if I head back to the plan view, I can click Set for the top, and it's going to be the seat reference plane. For now, I'm going to finish it and let it build it. Now, we're going to click and drag and pull the ends so you can see how it's blending. It's going to be a slight blend because of the distance that it needs to go for blending up, and the diameters are very close to each other. So what we need to do is take this and pull this down to where we want, which is that plane, and lock it. Whoops. If you get that happening a lot, change your mouse or adjust the mouse sensitivity level, if you can do it. And then let's pull that out again, just to be safe. Pull it back in, lock it. Now this is telling me constraints are not satisfied, so we need to expand and figure out what's happening here. And can't create the blend, so let's see if we can force it to edit the top. And let's set this back to level 1 for now and finish it. And go back to the front elevation. And we're going to, again, pull this out and pull this one out. So we do want this one to go to here and lock it. And then this one here to this reference plane and lock it. Good. I'm not going to worry about the materials right now. We're just building the basic shape and the form. So if we've done our math properly and the formulas properly, if I were to go in here and change the post support to say 2 inches, all these should change by default. And it should still adjust and hold in that shape, which it's doing. If it doesn't, then we need to make the necessary corrections to the formulas. Now that that's finished, we can start looking at the seat. So let's bring the picture back. And we see that the seat has this interesting shape that is vertical, and then there's a curve, and horizontal, and then there's a curve, and there's some void extrusion cutouts here and here. I won't worry about the cushion for now. Let's just work on the support. So if this is the front and this is the back, we want to head over to the right or the left side to do the profile. This, bend, horizontal, bend, vertical, kind of vertical, looks a little slightly bent, and then let it extrude in that linear direction. Okay? Again, since we've done a little bit of work, we need to save our work. And we do want to make some quick adjustments. This bar stool is not that wide. It's not 4 feet 10. So let's change the, let's make, since this is the front, we're going to select this dimension and parameterize this dimension and call it the bar stool width. And then we'll make it the appropriate size. Let's do 30 inches. And it adjusts accordingly. Let's head back to the plan view. And the depth also needs to be adjusted. So we'll parameterize that and call it bar stool depth. And we'll make it as well For now, 30 inches makes it easier to work with. As you can tell, the naming convention, be very cognizant of your naming convention. Make it consistent. Keep the caps if you want to work with caps. Use underscore for spaces. And because it all ties back to the formulas and making sure that it's named properly, because if you don't do that, the formulas don't work. And plus, it just makes things look a little neater and cleaner. Okay, so now we want to head over to, in this case, from our picture, I'm going to head over to the right elevation. And again, do ZA for zoom all. I'll do SD to shade. And we know that this bar stool shape has a thickness. And I'm going to set it to 1 inch thick for now. So I'm going to create reference planes using the pick method this time of 1 inch. And we want it to go up here. We want back here. We want out here. Now, we also want from the picture this vertical portion that comes down to come down to some stopping point over here. I assume that's where people will want to bend their knees and then their feet kind of lodge themselves here, their heels of their shoes lodge themselves here. So we want to create a reference plane for that down here somewhere. And let's set that one right now to say roughly 2 feet. It might be a little low. Let's do 1'6". Okay, and we'll just hold it there for now. So if you can kind of imagine, we're going to draw it from here to here, across to here, and back up, and then back down like this. The back portion over here, from the picture, looks like it's slightly slanted. I'm not going to worry about it for the sake of this video. We're just going to build it clean like this for now. So then again, I'll go to click Create. I'll do Extrusion. And then I will use the pick method, pick line method, with a lock feature. It makes it a little easier for me to draw them and lock them at the same time. And then I can use the trim to corner command to clean up the line work. Oops. And so this is what our profile is going to look like, and it's going to extrude away from my face toward into the screen. And if I go to the front elevation, you're going to see it gets extruded to the left. If I hit the green check mark, it'll build it, or the right, depending on which way I'm looking. And then we can push and pull these ends so that they align and lock to the planes that we need that define the overall width as well of that bar stool. If I look at this in 3D and shade it, you can see that's what we have so far. Pretty raw. Okay. So what we don't need to do now is we need to create the cutouts from the picture, which is here and up here. So we want to head over to this elevation here, which is the front elevation. And we can draw that opening. So the opening is going to be somewhere around here and over here and over here and up here. So let's again create some reference planes that define the limits of that opening. And again, making sure that when you draw the reference planes, you draw them so that they are nice and lined up. It's kind of good practice. We do need to set a limit for the spacing and the opening. So there's that frame here, 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 and up here. And they need to be, from the picture, it needs to look roughly 1.5 inches or so. So if I select this reference plane, I can set this to say 1.75 inches. Let's set it to 2. I think that's a little narrow. Oops, 2 inches, not 2 feet. Don't forget, Revit defaults to feet, not inches. So we'll do that one there. We'll set this one as well. This one down here. And this one up here. Now we've set them, but we haven't locked them. You want to make sure that you lock them with the dimension. That way they hold nicely. Because if we don't do that right now and leave it the way it is, it's going to mess up on us. So we need to place dimensions and lock that. And also I'll set the scale to 1 inch as well. Makes it a little easier to read. Okay, so now we can create this void extrusion. If we head over to the extrusion command, that's for solid. If we head over here to void forms, we can click void extrusion. And then we can use the box command again and click from here to here to here and lock all 4 sides. Again, we can use this command here to specify with a radius of 2 inches and let it put in that radius. I think the 2-inch radius might be a little large, but that's okay. Don't forget to lock your tangencies. And it may be a little hard to see that icon. It has to do with the resolution of your screen. So now that you've created that void extrusion, we want to head over to the left elevation or the right elevation. And again, shade it up and set the scale to 1 inch. Makes it easier. Finish it. Let that void finish. Now, that void has a front and a back. You can see it. It needs to be placed so that it aligns and locks to the reference planes that control the face of that geometry. And it also knows eventually what it's going to cut. So to make this void cut this form, just use the cut geometry command to select the chair and that void, and it opens it up. In the same vein, we want to do the opening over here as well. So I'll head over to the front elevation and draw one over here. So let's go ahead and quickly build the reference planes that we need. And from the picture, looks like it's roughly here. And again, place the dimensions. And we'll lock it at 2, that's fine. And to set this one to 2, zoom in a little bit. And then this one as well. And since we've adjusted them, we need to lock them as well. So again, same procedure. Create, void extrusion. If by chance you use the extrusion command and did it, it's okay, because if you select the form, you can actually go here under the properties and you can adjust it when you're making it to go from solid to void. So let's go over to void extrusion. Again, rectangle. Lock it. Same command here. This time I'm going to do a radius of 0.5 inches. I don't need it to be that big. That'll work. Don't forget your tangency locks. And you may need to zoom in order to see the locks and also to select them so you don't conflict yourself with other locks that are available, because you might accidentally unlock a lock. Again, head over to the left or right elevation, finish the command, and let it finish. And then push and pull the faces of the planes of the voids so that they agree to the correct reference planes. And if we head over to the 3D view, we should see it. And again, use the cut geometry command. And there you go. Now, let's take a look at some basics of materials. From the picture, it looks like the base and the post and the blend is all some type of black anodized metal, and then there's chrome. So let's go ahead and set that up. If I select this form, hold the control key down and select this form, zoom in here, hold the control and select that form, I can take all of them and click this little button over here that's called Associate Family Parameter and open up the Associate Family Parameter window. Here I can create a new parameter and call this bar stool support material. And the reason we do this is because all three now can be controlled by one parameter right here. And I can click inside and make it anything that I want. So we wanted some kind of black metal, right? So let's just type in metal under the search field and let it find all the metal that we've got. And so you'll see there are no materials for metal that are currently in the family, which is this upper left quadrant. And the lower right quadrant lists all the materials that are available in both your libraries of Autodesk materials and AEC materials. So let's look at just metals under Autodesk materials. And let's look under, how about this one? This one I'll do. We'll click this little button here to copy that material and that asset to our current family. And then we can head over to the Appearance tab and see what it looks like. Matte, finish, that's fine. Click OK, and now it gets adjusted. If we want to see it a little better in regards to materials, switch your visual style to realistic. Okay? And so now we can slightly get a different look. Heading back to the picture, we still have that little chrome piece and we have the wood. So let's go in here. Select that little piece right there. Parameterize this as well. And just call this bar stool inner support. Click OK and head over to the family types window and set this to be, oops, let's back out a little bit. I think we messed up. And let's set this to realistic again. Okay, so I need to look at that. This is material. Click here. And we want to call it bar stool support inner material. Because, oops, sorry, my fault. We want to click new here, not search, and put in bar stool inner support. Okay, so now let's head back over to the family types window. There we go. We can click inside here and make it chrome. So just type in chrome, hit enter, find it. Let's just say stainless steel chrome. That's fine, plated. Let's see what it looks like appearance-wise. That's fine. Click OK, and apply, and OK, and we're good. Now, I'm going to head back to the family types window because I think I saw a typo. Here, post inner support. So I typed it in correctly, so you can click in here and click this command to edit the parameter and fix the name. The last thing we need is the seat itself. So if I select this extrusion Again, we can go here, create a new one, bar seat material. And then go in here and give it material. Let's look at wood and see all the different types of wood that we have. Wood shake, flooring, wood, walnut, teak. Let's see what teak looks like. Okay, let's try teak. We'll add that to our current list of materials. Now, when we're working with materials, by the way, if I select this object, I can force it to be a material. I can just type in here any material that I want, or browse to the material dialog box and force it to be a material. If I do that, it becomes that material and it stays that material, and the only way to change it is to edit the family. However, the way I did it, where I'm associating it to a material parameter, the end user can just click inside the type property dialog box and click inside here and just make the change on the fly. They don't actually have to open up the family. Okay, so this is a good quick tutorial video on how to build the family. Again, don't forget to save your work and don't forget to flex it. So if I go in here and let's horse around with some of the dimensions and let's see how well it flexes. I'm gonna take this window and move it this way. And we can resize this window too, by the way. So I'm going to go in here and make this 2 feet instead. And make this, say, 3 feet instead. And make this 2 inches. And hit apply. Now, something's wrong, obviously, because it says constraints are not satisfied. So what we want to do is we want to cancel this. We don't want to remove the constraints yet. Cancel this. And go back and do it again, but this time when you flex, only do one at a time. So if I make this 3 for the depth, does it apply? No, something's not right. So we have to go back to the depth part. So we go back to the plan view and go over here where it says depth. So why is this not letting me flex all of a sudden? Something along the line has changed. So if I go in here and put this to 3 feet and say remove constraints, it can't make a certain extrusion. So if I hit delete element, it's going to remove that extrusion. Click OK and go look and see what got messed up. It's the actual seat that got messed up. Okay, I see what's going on. So I'm going to undo this. And we're going to go back to the sketch of this extrusion. So go back to the front, the left or the right elevation. Go back to this one. And the thickness that we specified, 1 inch thickness here and here and here, we didn't actually lock that thickness down. So let's go ahead and dimension here to here and lock it. Let's dimension here to here and lock it, and dimension here to here and lock it. That way that seat knows it's that thickness and it should hold that thickness. If I go in and I change this depth again to say 3 feet and I hit apply, it works. See? If I change this to 3 feet and I hit apply, it works. I don't see it in this view, but I can head over to a 3D view. And you can see it gets adjusted. Now, if I go to 2 feet and 2 feet, does it work? Yes. And as you can see, and let's change this to 2 inches and see if it adjusts. Yep, it adjusts. Okay. So we figured out what the initial issue was and why it wasn't flexing properly. And now that we've flexed it properly, we're good to go. So this is a good intro video tutorial on how to build a bar stool family using basic commands like the extrude and the blend. And we haven't done any family or work yet to do, say, sweeps or swept blends, but we did also do void extrusion as well. And we learned the principles behind how to create reference planes and how to create dimensions and the relationship of the objects to those planes. Thank you very much for watching. If you have any questions or anything, just let me know. And if you would like the family, just let me know as well. All right? And again, this is on with Repro Products. This, by the way, is just one of the videos that I'm starting. I'm going to start building other families and doing the same procedure. So the next one is going to be a table. All right? Thank you. Bye-bye.